So hello guys, welcome back once again to online class for excellence. Today we will be going with the chapter work, power and energy, the section energy. So last class I have discussed about what is work, different kinds of work, and I will illustrate some examples as well. So now today I will go with the energy part. So what is energy? Energy is nothing but the capability of doing work. So the capability of doing work. So when you are doing a work, so the capability of doing a work is energy. For example, suppose a nail is over here, I'm like pressing it against a wood via a hammer. So when I'm pulling the hammer like this upwards and putting it downwards in order to push the nail in the wood, so basically I'm doing a work. So the ability to do this work is what I possess, or what every like particles, every being possess is energy. So now before going into the types of energy, I will go with the unit one. So unit is same as work. So SI is nothing but joule, and Cbse unit is like arc. So these are same as, so work unit and energy unit, these both are same. And one more unit you need to like know, because in examination some will come, and like I will discuss the mathematical problem as well, but one more unit you need to know, that is electrical unit of electrical energy unit. You can say electrical energy unit is nothing but kilowatt. Okay, in an electric bill and all, you will see the bill is coming, so kilowatt, so what is kilo and watt and all other things, I will get into those, but mainly you need to know like what is basically electrical energy unit. It is basically kilowatt, like watt. Okay, so watt. So it is nothing but it is energy spent for doing a work, for doing completing a like power, completing a particular unit of power within 1 hour. So this is a different unit rather than joule and watt. I will come to you regarding this in the next section, but first I will continue with some other units, like one other is there like thermal unit, thermal unit regarding to heat and energy. So thermal unit, you can say that is the calorie energy. So remember one thing that I would like to say, like over here, one calorie is equal to 4.2 joule. Remember this relation, because it may come handy during solving the problem. So 1 calorie is equal to 4.2 joule. And if I consider the atomic structure and all, electron and proton and all, so it is like 1 eV. 1 eV is 1 electron volt, and so 1 electron volt is nothing but 1.6 into 10 to the power of minus 15 joule. You can like remember these two relation. You can use it in solving the summations or solving the problems. So now next I will come to the part like what is power. So this is like energy, the unit, the kind of thing that you need as theoretically. Before I am going to types of energy, I will come to the power, the basic things, what is power and what is the unit of power. Then I will discuss one or two sums regarding last class work and today's class energy and power. Then I will get into the details of what is types of, how many types of powers are there, or how many types of energies are there. So let's come to what is power. So like this is the third entity of this chapter, like power. So power, what is power? Power is nothing but rate of doing work, like rate of doing work. Rate means basically I will consider over here as rate means per second, per time, per hour, but like basically when per hour, the speed, per second. So this is called rate, that is related to time. So over here power is rate of doing work. So power is, this is work and this is the time. Consider it, I will again tell you, like you will take time as seconds in like mostly these general cases, because in SI as well as Cbse system the time unit is seconds. So power is equal to W by T. W is equal to work, and time, that is the time taken. P, again another P is like power, again another relation is there. As you know, work done is equal to energy lost or gain. So P is equal to E by T, energy by T. When you will come to understand like the mathematical, I've told you about this work, like W is nothing but F into S. You can check my last video, F into S is W. And E I will come to you in the next class, like what is E and what is the measurement of E during, I will solve it during like mathematical solution. So over here, one more thing is like what is the SI unit of power, and arc per second is the SI unit of power in CGS category. So arc per second is the CGS, and watt is nothing but, you can say watt is nothing but joule per second, joule per second, because joule is the SI unit of work or energy. And one more thing you can understand, or can as I've written over here, HP, horsepower. So horsepower is another kind of like in engine and all, where huge machineries are used, huge power is needed. So it is a greater unit of power, that is 1 HP, horsepower is equal to 746 watt. You can memorize this, because this, again I'm telling you one thing, this can come in handy while solving the problem. So this is power equal to W by T and P equal to E by T. Now I will come back to some basic sums of work power, but first I will deduct one more formula for you guys for this power formula. As you can see, P is equal to W by T. So W, as you know, is equal to F into S by T. So F into S is by T. So what is S? S is a displacement. The body is moving. I'm doing a work, and the object is moving in the direction of the work. So S is a displacement. So S by T, if I can say displacement by time, as you know from a previous class 7, 6, 7, 8 and all. So S by D, T is nothing but F into V. So force into velocity. So if one more formula is there, like power is equal to force into velocity. If there is no displacement given, time given, you can like calculate power by using this formula, force into velocity. Velocity is nothing but displacement by time. So I will come back again, like now only for the basic sum formulas. You guys, if you need some time, pause the video, write it down, because these are the main factors that you need for examination. I'm going through the main sections only because I don't have any like time, because I know like exams are near, so I have to complete the section for class 10 basically in almost within 1 month. So you guys can note it down while pausing my video, and I'm coming back with the solution as well. So energy, these are the type of energy. तो लाइक हम लोग इधर देख रहे हैं कि 1, 2, 3, 4, 5, 6 रकम का एनर्जी लिख मैं चुका हूँ, और भी एनर्जीज है. तो फॉर योर सिलेबस यू नीड दिस 6 काइंड ऑफ एनर्जीज. Number 1, mechanical. What is mechanical energy? Mechanical energy is something like that you possess in a state of rest or in a state of motion, like when you are moving, when you are sitting and all. The state is like when you are at a state of rest or at a state of motion. So the main energy that you are holding in your body while you are at rest or you are at motion is mechanical energy. Then coming chemical energy. Chemical is basically nothing but the like chemical bondings and all in your body. The molecules, the atoms and all, the chemical energy that is being built up of. Heat you as know, like the body, the temperature, the heat your body is holding, temperature, a kind of energy it is holding. Light, energy like for visual effect. The energy that is being produced for your visual effects, so you can see an object in front of you. Sound is again an energy that is helping you to see the object as well as hear. Light and sound are related, so sound helps you to hear what you are seeing. Suppose like you are hearing this video, a frequency, a wave is going in your ear via this video. So sound is that energy. Nuclear energy is something like which happens sometimes in nuclear fission and fusion, like in nuclear bomb, atom bomb and all. So this kind of energies you need to remember the definitions, and I will tell you the transformation as well, like from chemical to heat, light to sound, sound to nuclear, etc., etc. that you guys need in your exam. And the main two part, that is kinetic energy and the potential energy. Kinetic energy is what? Like the body when it is in motion. So related to that, it's kinetic energy, motion. And potential is what? When it is, a body is at rest. It may be at sea level or it may be at a height. Suppose I'm standing over here at a certain level of height. Now when you are in a mountain or something like that, you are at a certain height, but you are at a rest. So potential energy is when you are at a rest, no matter height is. So you need to calculate this kinetic and potential much more for your algebraic sums, or as mainly algebraic and arithmetic sums. So these are the part. So I will come back again with the formulas of kinetic and potential energy. Till then, write down as much as you can. So now let's come back to the formulas of kinetic energy and potential energy. You guys need this formula for solving the problem. Let us come to the kinetic energy part. So kinetic energy is denoted by Es equal to half mv square. What is m? M is the mass and v is velocity. Okay. So as I've told you, what is kinetic energy? Kinetic energy, that is the energy that you are having when you are in a motion. That is, you are having a particular velocity, you are moving. So as I've told you, work done is equal to energy gained. I am deriving this formula. So work done is equal to energy gained is equal to the F into S, force into displacement, because work done is equal to force into displacement, that is nothing but the energy gained. So you know this formula, this you need for derivation, different formula for like motion. You know v square is the final velocity minus u square initial velocity, u is the initial velocity, is equal to 2as. A is the acceleration, s is the distance covered. So the force is being applied on this object. Initial velocity is 0, now it is moving, so final velocity is v. So initial is 0. Now from here we get to know A equal to v square by 2s. So if now again another formula from Newton's formula, force and motion, from that chapter you know, force equal to mass into acceleration. So mass and acceleration is this. So basically it is coming Es, that is the force, Es equal to half mv square by s into s. Okay, into s, because why? F equal to Fs. So s is being multiplied over here, s is getting cancelled. So half mv square is the main term, like the main expression for kinetic energy. And now let's come to potential energy. It is nothing but the force being like applied, or the energy being gained when you are gaining some height from the sea level. So suppose you are over here, object is over here, the mass is m, and now the object is being moved upward by applying a force, and it is now over here at a height of distance, like at a distance of h, at a height of h from the ground level. So F equal to W into h. W is equal to the nothing but the weight. Weight is, as you know, W equal to mg. Weight equal to mg. Mass into acceleration due to gravity. So weight equal to mg into h. So mgh. Mgh is the expression for potential energy. Now I will come back to another just relation. Momentum you also guys know, like it is nothing but P, it is denoted by P, and it is m into V, mass into velocity. So if just a derivation for you guys, so that it will come handy for solving problems. So P equal to mv, so P square equal to m square is V square. Now what I am doing, just a derivation for you guys. P square by Es square. So this is kinetic energy. So kinetic energy and P square. P square is like the momentum, you can say, like the momentum. So over here, what you can say, so now when you are like doing this thing, like what should you do? Like what is happening over here? So P square by Es is coming like half mv square in below and mv square into v square upwards. So basically Es, so it's coming like equal to 2m. So Es equal to P square by 2m. So P is equal to 2m Es root, square root. So basically momentum is square root of 2m into kinetic energy. So now I will not write it over board, but I will go through some examples so that you can note it down as well. I'm going very slowly. So transformation of energy. So you guys know, like, energy can neither be created nor destroyed. It can be transformed from one form to another. So now, as suppose this light is glowing. How? So current, we are putting there the switch, the current is being transferred over here in the tube, and it is producing me light energy, as well as heat is also produced. So if you go in front of a light, you will feel the heat as well. So here the transformation is happening, but the net energy, the total energy is constant. It is just getting transformed from one form to another. So you can say this is the universal thing. You guys can notice it anywhere in your day-to-day appliances, day-to-day work as well. So just as I'm telling you, over here in the case of light, current is being converted to light, and light is being converted to heat. Okay, so this is one example. I will go through some example as well, like electric lamp, electric fan. What is happening? So electric fan, you may say current is producing electric fan mechanical because it is moving. You can say kinetic as well, but I will preferably say mechanical. So it is moving. So electrical energy is being converted to mechanical energy. So again, I will go with another example, like photoelectric cell. Photoelectric cell means like sunlight is coming. So from sunlight, from solar energy, it is being converted to light energy. So now again, like suppose wind electric generator, windmill. So kinetic energy, wind is being the kind mechanical energy is being converted to wind energy. And suppose burning of a candle, you can say chemical energy, the wask that is chemical. So wask, the chemical energy is being converted to light energy. And there are some more example like microphone, phone. So sound energy, when you are receiving it, so it is being converted to sound into electrical energy. Okay. Again, it's like a speaker was happening, the electrical energy is being converted to sound energy. So there are various kind of example. You can follow a book, you can follow a textbook as well, because these questions come in objectives as well. Now I will come back to one more thing. So this also I will tell you in brief only. So mechanical energy, the main energy is remaining constant, as I have told you. So I will give you one just a small example regarding this. So first I will say, like, when a body, as I have told you, in case of potential energy, a body is being maintained at a certain height. So over here, if I say at a certain height, the body is over here and it is coming over here. So it is falling, okay, it is falling down. So total mechanical energy, the total mechanical energy is the energy that the body is holding. Suppose the body is over here right now at a height of h. So potential energy it is having mgh according to this. So mgh, the total energy that the body is having over here is mgh, because it is having the potential energy and it is not having any kinetic energy, because the body is at rest. It is at rest. Now suppose it is coming over here. It has come over half distance over here. So again, mechanical energy is total is nothing but the half of this plus it is having some kinetic energy as well, because it is moving with some velocity. Again, when it is coming over here, it is not having it is having a minimal height before hitting the ground. So when it is landing, main energy is nothing but half mv square. Whole is kinetic energy. Whole thing, the kinetic energy. There is no, because it is a minimal height, so potential energy will take it at 0. So if you see at the main half is like half kinetic, half potential. In the top, potential, and in the below, kinetic. So potential is being converted to kinetic energy as well. So this is also transformation of energy. In case of pendulum as well, pendulum, you can say like the bob of the pendulum is moving like this. So it is forming a trajectory like this. So it is moving over here and here. So when it is coming over here, it is at a minimal height. So when it is moving over here, it is having a height. It is gaining a height. So kinetic energy, here potential, here kinetic. Kinetic potential, kinetic potential. The transformation is happening. And I will say you one more thing. So you need it when the pendulum is moving in this position. Suppose a height of h. Remember this expression just for your some like problems. So h equal to v square by 2g. G is the acceleration due to gravity. V square is the velocity. The bob is moving over here. So this H, when the bob of this pendulum is like going in the extreme height, so this height is equal to V square by 2G. Remember this expression for summation problem. So this is mainly the theoretical part of watt power energy. I will come back with you guys with some problem and you will solve it in your home. I will discuss it with you guys. So till then, go through this part, pause it. You can write down the formulas. If you have any queries, you can comment in the comment section. Do subscribe to our channel, please. Share the video with your peers, with your students, so that I can also keep on moving with you guys. So let's come back with the solutions. So like guys, these are the sums that I given for you. You guys solve it. I will just give you the hints in this section. In this session mainly. Then I will discuss the answers in the next session. So do the sum in your like home. I will just discuss the sum with you guys once. If a mass M, I've written it in short because I've got like less space, so that's why I've written it in like denotions. As you can see, like M is mass, so mass is equal to 50 gram volume. Velocity, V is velocity. So velocity. So 10 meter per second. So find the kinetic energy. So you know the formula, guys. So half mv square you know. New kinetic energy, mass is doubled. So if the mass is being doubled, so kinetic energy just depends like directly proportional to mass. So if the mass is being doubled, the kinetic energy will also get doubled. So you guys solve it and I will discuss the answers. And velocity mv square. So velocity is basically nothing but it's E is directly proportional to V square, and if A and V are both double, then you can say like this is also double, this is also double. So solve this sum. So next is like P, potential energy of an object of mass is 24 kg, is raised to a height, is being raised to a height, and potential energy is like 7200 joule. So the body is being like moved to a certain height. So potential energy, find the height. So this is the basically potential energy. So you have to find the height and the number of stories in the building. If this is a building, you can say how many stories, how many floors are there in the building. If each floor is 3 meter, so you have to need to find the height mainly through the formula P, like P equal to potential energy equal to mgh. So height, and you can divide h by like the 3. So you can get the number of steps, because if each step is like 3, then you can, when you find the total height, it's easier for you to just divide it. Now third, boy weighing 40 like kilogram force climbs 30 steps 20 centimeters in 4 minutes, and a girl weighing 30 kg force in 3 minutes. Compare the work done and power developed. So this sum I will not tell you anything, because you need to do it on yourself. Like power developed, I can say like you can use that formula W by T. So work done, if you once you find the work done, so power is equal to W by T. But I'm again telling you same thing. Work done is equal to energy. So over here height is given, distance is given, weight is given. So you guys know you have to use potential energy formula. Do it. Object thrown with next sum, number 4. Object thrown with kinetic energy 20 joule from the ground. So I'm putting it from the ground and I'm throwing it, and it is like I'm throwing it with the velocity. So kinetic energy initially is 20 joule, and it is moving to a certain height h, that is 10 meter, mass of object. So mainly the thing is like that kinetic energy is equal to potential energy, you know. So mgh is equal to half mv square in this case. So mass of object and all. So in this case kinetic energy is nothing but the potential energy only that the body is reaching as it is getting the height. So you can find the mass of object. Mass, again number 5, mass is 10 kg drop from, is being dropped from certain height. So find the P. P is the initial, K at ground the lower point. So P and this will be equal, because at the height it has potential energy and at the lowest it has kinetic energy only. And V before hitting the ground, the velocity before hitting the ground, the object is being heated. So that is the same thing, half mv square. You guys can use this formula. And last is like a mass of 0.2 kg is being moved from point A, that is at a height of like 1200 meter to height of 1800 meter, point B. From A to B it is being moved. So work is done. So how much work is done? You will also the same thing, the height, the mass is there. So energy is being used, so you can use the work in. And for work done, I'm again telling you, work done is nothing but you can use the formulas of potential energy and kinetic energy, like work done equal to energy gained or loss. And another formula, W equal to Fs, this you can use it for smaller like objective kind of sums. So guys, this is the main thing for work, power, energy in a nutshell. You guys go through the whole video, share it and subscribe to my channel. If you guys have any query, do tell me in your comment section, and I will discuss you with any problem if you have regarding this kind of solutions. Do comment me in the comment section. I will come back with a solution in the next video. Probably I will start with biology or chemistry of class 10 as well in the next session. Thank you.